Hello, everybody. This is Sunday. It's January 16th, and we are headed into the second week of our online astronomy course. Now, before we get into the contents of Module 2, I want to share some of the astronomy news that's been going on this past week. The James Webb Space Telescope is continuing with its journey out to its final destination, where it will be making its observations. It will get there on January 29th, so a little bit under 2 weeks from now. And the James Webb Space Telescope has 18 mirrors that will come together to form one large mirror, about 6.5 meters across. And each one of those 18 mirrors has 6 actuators, 6 little motors that can change the exact position of the mirror, can even change the shape of the mirror. And all those had to be woken up. They were stored during launch. Those actuators had to be activated. They've all been activated. And so that's really the final step, except for getting Webb to its final destination spot. So good news for the James Webb Space Telescope. Not so much good news for the Perseverance rover that is on the surface of Mars. And what's going on with that is that the Perseverance rover has been taking samples of the Martian crust. And so what has been happening is that it drills down and takes a little core sample. And you can see that here. Right here, you can look into this little tube and you can see a sample of the Martian crust. What happens is that tube is going to be closed off. It's going to be stored inside the Perseverance rover, and then finally left on the surface to be picked up by a later mission. So here you can see on the rock, here's some holes that the Perseverance drill has dug down into the Martian surface. It's pulled out a little tube, and each one of those little tubes is about the size of your finger, about, a little bit about that long, and it has to be stored. But what's happened is that you can see here down at the bottom that there is some rock that has some little pebbles that are keeping the tube from being passed and stored in the Perseverance rover, passed from the drill to the Perseverance rover. And so NASA's trying to figure a way of how to get rid of these little pebbles. So it's amazing that something so small as a little pebble is holding up progress right now on the Perseverance rover on Mars. I'm sure they'll solve this, but for right now, it is something of a problem. Okay, let's move into Module 2. Module 2, we're going to talk about the motions of the stars in the sky. Now, you already know about how stars rise in the east and they set in the west. And of course, the stars aren't moving. It's really the Earth that's rotating. The surface of the Earth rotates from west toward the east. And so as you get closer, as you move toward the east, those stars that are in the east rise up above the horizon. They move across the sky and they set in the west. But the Greeks knew about other objects, planets, which, as I explained last week, means wanderer in Greek. Planets are objects that wander across the sky. And from night to night, they can watch this happening as planets move past different stars that are in the sky. Now, here's the picture I showed you last week. This is on the shore of Summit Lake in Lassen Volcanic National Park. Right now I'm standing on the north shore. And so when I took the picture, I was looking south. And when you look at your screen, you too are looking south. Now remember, if you're looking south and you stretch out your left hand, then you're pointing to the east. And if you stretch out your right hand, you're pointed to the west. So on your screen, east is to the left and west is to the right. So let's take a look at the 2 planets we can see in this picture. If I take a look right here, this brighter planet is Mars. And Mars from night to night normally moves eastward. So Mars might be here one night, the next night it's going to be here, and the next night it's going to be here. Next night it's going to be here against the distant background stars. Next night it's going to be here. Next night it's going to be here. And so this eastward motion is normal for a planet. You know, this over here is Saturn, and it too will be moving eastward from night to night to night. This direct motion is the normal motion. But every once in a while, the planets go backwards. So it's like Mars here would be going eastward. So it might be going from here to here against the stars, from here to here, from here to here, from here to here. And then all of a sudden, it's going to change direction. So it's going to go from here to here, and from here to here, and from here to here. It's going backwards to the west, backwards. And that's called retrograde motion. And then after a while, it's done doing that, and it starts moving eastward again from night to night. Here to here to here. And Saturn will do the same thing. All of the planets exhibit retrograde Martian. And this just drove the Greeks absolutely nuts. They could not understand this at all, because in their mind, everything moved in circles. You know, circles were the perfect shape, and it was the dogma of the time that everything had to move in perfect circles. And it makes sense that if all the stars, you know, were circling Earth once per day, we now know that's due to Earth's rotation. They didn't know that. But to them, you know, they were thinking, well, gosh, all the stars are circling Earth in a day. Everything should go around Earth in a perfect circle. That was called a geocentric solar system. Geo meaning Earth, centric, centered. So the Greeks had this geocentric solar system in which everything moved in circles around Earth. But if everything's moving in a circle around Earth, then how is it that Mars is going to go to the east and then backs up and go to the west in retrograde motion and then go east again? Oh my gosh, how can you explain that? Because the only motion that's allowed in the heavens is circular motion. Well, as you'll find out in this module, it was came to us a man named Ptolemy to perfect the idea of how stars moved. How planets moved, and how planets could move just in circles and still back up and go forward again. They can't back up on their circular motion. But if you have a circle operating within a circle, then they can. And that was Ptolemy's idea. So for instance, I'm going to try to show you this. I'm going to be moving my hand steadily to the east, but I'm going to be moving my finger in a little circle at the same time. Okay. So watch this. I'm going to be moving my hand slowly to the east, but my finger is going to be moving in a circle at the same time. So my hand's moving around Earth in a large circle, and the planet is attached to the end of my finger, and it's moving in a small circle. So watch what happens. I'm moving my hand slowly to that way. And if you just look on the screen, you'll see that sometimes, although my hand never backed up, and my finger was always going around the circle in the same direction, the planet at the end of my finger would have been going in the opposite direction, backwards sometimes. Well, if that didn't make sense to you, there's an animation you should really watch. This was Ptolemy's explanation of the geocentric universe and his explanation of retrograde motion. So you're also going to find out there's a little bit of math in this module, not a lot. So please look at the introduction to Module 2 because I work examples of the math, and you can just use that as a template, as a blueprint for showing you how to do these problems on the Module 2 homework quizzes. Remember, you won't have to do the math on the tests, but I do want to show you math on the homework quizzes because math is how we understand what's in the sky and how it all works. So I think that this is such an interesting history of how astronomy came to be, the early history of astronomy, and how finally people figured out that no, this whole thing about circles moving inside of circles, just abandoned. And that was abandoned by somebody named Nikolai Copernicus. And Copernicus displaced Earth from the center of the solar system and put the sun at the center where it belongs. And you'll learn about that too. So that's all in Module 2. And I want to share what's in the night sky tonight, because tomorrow night, which is the 17th, that's Monday night, is going to be the full moon. So let's take a look at the full moon. And so here's Stellarium. I pulled it up for tomorrow night around 10 at night. We're looking southeast, and there's the full moon. Now, if you're just looking to the south, you'll see some familiar things. You'll see Orion up there. There's the constellation of Orion. Here's Sirius, the brightest appearing star in the sky. But if you turn your head to the left to look southeast, you'll see the full moon up there. And what's really cool, I'll just pan down to the moon and you can see it. And above the full moon, I'll zoom into it just for a second here to show you that it is a full moon. There it is. So there's my full moon. Zoom back out again. But above it are two bright stars. Above the full moon are two bright stars, and those are Pollux and Castor, and they're part of the constellation of Gemini. So let me put up the constellation lines there. You can see this looks like two figures. They're lying on their side right now. So here's Pollux at the head of this figure, and here's the star Castor at the head of this figure. And these twins are the constellation Gemini. And in fact, if here are the labels, there's Gemini identified. And if I put on the figures, you can see here are the two twins. I'll get rid of the figures for right now. But it's interesting, in Greek mythology, Castor and Pollux had the same mother, but different fathers. Castor, the dimmer one, had a mortal father. He was king of Sparta. Whereas Pollux, his father, was Zeus, king of the gods. But they are up there together, Gemini. Gemini in Latin actually means twins. So there's the constellation of Gemini, and these two stars are right above the full moon. So if you want to know where Gemini is, you can take a look tomorrow night, because that's when the moon will be directly under Castor and Pollux. So I hope you enjoy learning about this early history of astronomy, how we came to understand our real place in the solar system. And if you have any questions, as always, you're welcome to ask a question in the discussions. I'll be happy to set up a Zoom meeting with you, or you're welcome to come by my office and see me in person. And if you want to set up a Zoom meeting, come in person, just send me an email. And you're also welcome to ask a question in the email. Just drop me an email, but send me an email and I'll be happy to set up a meeting with you. So hope you enjoy learning about this early history of astronomy, and I will look forward to seeing you next week. So until then, bye-bye.